Welcome back to our lecture series on grad, call, and dive. So, in this video, we are going to be looking at this example, and this look a little different from the ones we have been looking at in the past. All right, so the question says, if file, which is actually the function, is equals to xyz minus 2y squared z plus x squared z squared, we are asked to determine the dive grad file at point 241. So this is something that I've mentioned in some of the previous examples, that sometimes they might just give you only the notation and sometimes they can just spell it out. Exactly. So for this now, they just wrote it out as dive grad of file. So they didn't even give what the notation actually is. So that's how some questions can be. Some they can just give you both of them. Exactly. So like I made mention, especially in the last video, you need to really understand some of these terms. So once you see it in question, you will know what they're asking you. Because what I just noticed is that sometimes you might know how to find the dive, how to find the grad, how to find the call, but when it comes to the notation, quite a number of people usually mix it up. All right, so now let's do this. So basically, in summary, what you are asked to look for is this. So this is same as having the dive, so what this actually means is, so once you are doing a question like this, always start from the right, the ones at the right. So what actually means is that first you have to look for the grad of file. So you look for the grad of file. So whatever you get as your answer, you're going to use it to look for the dive. Exactly. So you're going to be having the dive of whatever you get here. Exactly. That's more like the dot product of it. So that's just a summary of what the question is talking about. But all right, so let's do that. So let's just write out. Like I said, we are going to calculate. First of all, we are going to calculate the grad. So we are going to first calculate for grad file. Exactly. And if you have been following, we've already established the fact that for grad file, the formula is given as, when you have grad file, is partial differential of phi over dx of I plus partial differential of phi over dy of j plus of phi over dx and z and then k. Exactly. So so that's the formula there. So now let's put in the values. So that means our grad phi is equals to over dx of the function it has x y z minus 2y squared z plus x squared z squared, close the brackets, don't forget your I, plus the partial differential of a partial differential of z. So the function again, x y z minus 2y squared z plus x squared z squared, and then this is for j, and then for k, so that will be plus, okay, let me just put it here, partial differential, okay, so this is for y, and then this is for z, of x y z minus 2y squared z plus x squared z squared ijk. So now let's tidy it up. So now let's start with this. So if we are to differentiate what we are having here with respect to x, so we are having x here. So if you are to differentiate that, if you differentiate x, that would be 1. So y and z will remain. So let me just put the I. Okay, so let's just put that in brackets. So that will be yz. So this will be 0 because we don't have x here. Y for this, we already have x, which is x squared. So if you differentiate x squared, that will give us 2x. Then z squared will remain as a constant. So that will be plus 2x z squared. So we can go ahead and close this and then put our coordinate I. Then plus. So now let's come over to this one here. So we are differentiating with respect to y. So starting with this, we already have y here. So if you should differentiate that, y is 1. So we'll be left with x and z. So that will be x and z. Okay. So for this now, we already have y here. If you should differentiate y squared, so that would give us 2y. So the remaining ones will be constant. So that will be minus 2. Okay, so that will be minus 4 rather. The reason why it's minus 4, since these 2 here, we'll come and multiply these 2 here. So that will be minus 4z or minus 4yz. Yes. Then for this now, if you are differentiating with respect to y, so there's no y here, this is just 0. So we can go ahead and close our bracket and have j. So let's continue then plus, so this the last part. So we are differentiating now with respect to z. So if you differentiate this with respect to z, this z becomes 1. We'll be left with xy. Then here, if we should differentiate this with respect to z, so this our z becomes 1. So we'll be left with minus 2. So minus 2y squared. So for this now, if you should differentiate this with respect to z, so we are only having z here, which is z squared. So that z squared can be rewritten as 2, and if you differentiate that z squared, that will be 2z. So with that, we are going to be having plus 2x squared z. So if you close it, we are going to be having k. Okay. Alright, so now we have gotten grad file. So let's go ahead and calculate our div of file. So we've gotten our grad. So this is our grad. So now let's go ahead and calculate our div of the file. So this is the notation. That's so that will be equals to. So we are going to be having partial differential s of y of I plus partial differential. Okay, this is going to be x. Sorry. dy plus dz. This is I, j, and then k. So we use that to cross. The dot product of this entire one here. So that will be yz plus 2xz square I plus xz minus 4yzj plus xy minus 2y square plus 2x square z and then k. So just take note, there's a k here. Okay. Alright, so okay. So I can't remember where I paused the video, but I just noticed that I was recording, I was just doing without even pressing play. So I can't remember where I actually stopped, but anyways, if it was somewhere here, let me just go ahead and explain. So at this point here, we've gotten our grad. So here we are calculating for our div of grad. So remember, this formula here is for that of grad, for that of div, and you're going to use it to multiply the function itself. So just follow this arrow. So what we are having here, we are using it to multiply this. What we are having here, we are using it to multiply this, because this is I and I is multiplying each other. And you also need to note that you can't have a coordinate I using it to multiply a coordinate j or k. Exactly. So they have to be in the same coordinate. So with that now, so that's what I brought here. This here multiplied by what we are having here is what I've written out here. So for this, for the j coordinate, this j coordinate, I'm using it to also multiply the second j coordinate, and that is what we have here. Okay, and then for the k, this multiply this, and then that's what we have here. All right. So at this point now, we are just differentiating. So if you should differentiate what we are having here with respect to x, you are going to be having 2z squared. That's because if you look here, there is no x here, so that's 0. And here there is one x here. If you differentiate this x, to give you 1, so you'll be left with 2z squared. And that's why we are having 2z squared here. If you come over here, so we are going to be having plus. Now if you should differentiate what we are having here with respect to y, there is no y here, so this becomes 0. We are having y here, so if you differentiate this y, we are going to be getting 1, and we're left with minus 4z. So if you have minus 4z here, and remember plus times minus, and that will give us minus, so that's why we had minus here. So let's move to the next one. So for this now, so let's still put our plus. In case there's a minus, we can correct that. So if we should differentiate this now with respect to z, because we are differentiating with respect to z here, there is no z here, so this becomes 0. This place also, there is no z, so this also becomes 0. But here we are having a z value here, which is this. So if you differentiate that z, it is 1. So we'll be left with 2x squared. So that will be plus 2x squared. Are we good? All right. So, and if you go back to the question, we were told that at point 241. So at point 241, so that means our x is equals to 2, our y is equals to 4, and then xy, and then our z is equals to 1. Now, there's something I need to also explain at this point, is that when you are dealing with a question like this that has multiple functions, maybe you are dealing with grad and dive and call, once they have multiple, and they tell you that determine whatever it is. For example, this one is like determine grad file at point 241. Now you put in the value of 241 at the end of the answer. So what I'm saying is, so when you first of all calculate for grad file at this point, so when we got our grad file, this is it here. This is the point where we got our grad file. This is not where you have to substitute the value of x, y, and z. I hope that makes sense. So don't come here and say you are substituting your x, your y, your z, your 2. No, you don't do it here. You are going to do it at the end of the answer, which is this. Exactly. So if for any reason also this particular question is asking you to go ahead and use this to also look for maybe the grad of this function again. Exactly. If they ask to look for this grad of this function again, so you still use the same value. You will not input the value of x, y, and z at this point. I hope that makes sense. All right. So now we can, since we've looked at for the value till the end, we can go ahead and put in our x, y, and z. So that means our grad dot, our div grad file will then be, so 241. So now this will be, for this now, this will be 2 times z squared. Our z is 1, so that will be 1, and that will just give us 2. Then minus, for this now, this is 4 times, our z is 1, that's 1, that will be 2, 4. Then for 2x squared, we are having, that's 2 times, our x squared is 2 raised to power 2, that's 4, so that will give us 8, then plus 8. So if we should simplify this, we are having 2 minus 4 plus 8, and that will just give us 6. So we can just conclude that our div grad file is equals to 6, and this right here is the final answer to this example. So I hope you understand the concept. If you are yet to, just go through the example. You might need to watch it once or twice, but to understand the concept, somebody is distracting me here. So if you have any question or doubts, don't hesitate to leave them in the comment section. Don't forget to like, share, and subscribe to the channel. So I still have one more example that we are still going to be looking at on call, and then it's a lecture series, so every other thing on that call, dividend and gradient will be covered in the course of this lecture series. So I'll see you all in the next video.